Okay, today we're going to talk about a different numbering system. We've already gone over decimal. We went through the decimal numbering system. We went through the binary numbering system. And we went through the octal numbering system. And today we're going to do something a little different. Today we're going to talk about hexadecimal. Hexadecimal. When we went through decimal, we learned that we used characters 0 through 9 and then started over with 1, 0. In binary, we went 0 through 1 and started over. In octal, we go 0 through 7 and we start over. Well, with hexadecimal, we're going to get something really strange. We're going to go 0 through F, and then we're going to start over with 1, 0. So now, if I was talking decimal, if I was in the decimal system and I wanted to count up to 15, that would be what the number would look like. It would be 15, that's base 10. But in hexadecimal, I can count up to 15 with just one character. I can count your standard 0 through 9 that we would do in decimal, and then I'm going to use the letters A through F to count up to from 10 through 15. So this is 15 base 10 would look like that. 15 in hexadecimal, or base 16, would look like that. Would just be an F, one character. So we're going to count 0 through 9, and then 10 is going to equal A, the letter A. 11 is going to be B. 12 equals C. 13 equals D. 14 equals E. And 15 equals F. And then when we get to the number 16, these are all the base 10 numbers on this side, and these are all the hexadecimal numbers on that side. When we get to 16 in base 10, in hexadecimal, it would be 1, 0. So this would be our base 10, and this would be our base 16. So notice they're kind of mirrors of each other. But 16 is equal to 1, 0 in hexadecimal. So let's convert a number back and forth. Let's go back to our familiar 179 that we've used before in base 10. And we're going to convert that to hex. Sometimes hexadecimal is abbreviated. People just call it hex. So we're going to convert that number. And with every numbering system, we start off the same way. The first digit is to the 0 power, the next digit is to the first power, next digit is to the second power. So in hexadecimal, we would have the ones, again, like we always do. 16 to the 0 power would be 1. 16 to the first power would be the 16s. And the next digit is going to be 16 squared, or is going to be 256, if we did the math on that. So, and then we're going to go up from there. So I'm going to just deal with some smaller digits. Right now, we've only got 179 to convert, and that's less than 256. So if we're going to convert this into a hexadecimal number, then we're going to end up with only 2 digits, because we don't have enough for 256. We've only got enough for 16s. So how many 16s would we have in 179. If we divided that, I'll take that back, let's make that a division symbol, not a radical. So if we divided that by 16, we would find that 16 would go into this obviously 10 times, because that would be 160. If we added 16 to 160, we would get 176. So that's going to go 11 times. 11 times 16 is 176, and we're going to have 3 left over. So that's how many ones we're going to have left over. So we've got 11 16s and 3 1s. So converting to our hex number, we could put a 3 and then 11 times 16. So 11, what is 11 in hexadecimal? 11 is B. So the answer to our conversion here is B3. The number 179 in decimal is equal to B3 in hexadecimal. So the B stands for 11 16s and 3 1s. So 11 16s is 176 plus the 3 1s gives us 179. So that was a pretty easy conversion. And we'll see when we go to convert a hexadecimal number to binary, or a binary to hexadecimal, they convert fairly easily. So let's try our binary to hexadecimal number, and I'm just going to throw a different number out there. We're going to go 1 1 0 1 0 1 1 0. Let's try that. 8 digits, and what happens in going from binary to hexadecimal is that you can divide any binary number into sets of 4 digits, just like we did with octal, only instead of 3 digits at a time, we're going to do 4 digits at a time. And each one of these is going to stand for one of the digits in hexadecimal. So we would have, in binary, again, we'd have 1s, 2s, 4s, and 8s. So if all these bits were set, we would add up 8 plus 4 plus 2 plus 1. We would come up to 15. So these 4 digits added up would be 15, which would be an F in hexadecimal if they were all set. These aren't all set though. We've got a 4 and a 2. That's going to give us a 6. So over here we have a 1, and we have a 4 and an 8. So we've got 8 plus 4 is 12, plus 1 is 13. 13 in hexadecimal is D. So this number in binary, or base 2, is equal to this number in hexadecimal, or D6. So if we want to go the other way, we would just have to look up the equivalent, like this B3 here. If we wanted to convert that to binary, we'd say 3. Let's come up with let's make our little divider, and we're going to have 4 digits. So we don't have any 8s, we don't have any 4s, we've got a 2 and a 1. So to convert B into 4 binary digits, a B is an 11, so we know that's an odd number, so we can automatically put a 1 here. And then to get the remaining 10, we would have 8 plus 2. So we would have a 2, we would not have any 4s, and we would have an 8 value. So this in base 2 is the same as B3 in hexadecimal, or 179 in base 10. So a couple different methods of converting back and forth between binary and hexadecimal, and between decimal and hexadecimal. So hopefully you got a pretty good handle on all this by now, and try a few on your own, and we'll see you next time.